Okay, this is going to be another example about well, circuits, of course, but about the superposition of effects. Um, as a matter of fact, I'm going to be solving this problem using the superposition of effects once again. But it's going to be a slightly different problem than compared to the one I have already done. So, without any further explanation, let's just draw our new circuit this time. So we're going to have a generator of current, which is J, um, which in this circuit made like so. So till this point here, which we're going to call A. And then we're going to have, well, down here, we're going to have a resistance, and then another point, and then down here, another resistance, and then another point, and in between we're gonna have a generator, but this time of voltage, not of current, of voltage. And then down here we're gonna have resistance, and down here we're gonna have a resistance as well. There we go. And then all the way back to the source, so the generator of current. So this one is going to be my point A, as I said. Therefore, this one is going to be my point B. B. This one is J, generator of current. This one is plus minus V, generator of voltage. This one is R1, is resistance R1, R2, R3, no, I'm sorry, R4 and R5. And I'm going to tell you why I choose R4 and R5 shortly. Okay, so the problem is saying, for the circuit below, we know V, the generator of voltage, which is 6 volts, J, the generator of current, which is 5 amps, Ri is I ohm. Find the voltage across AB, so VAB. Okay, well, by the way, what I mean by Ri equal I, which I used in another problem as well, which is because, it's very common, is that, resistance 1 is going to be 1 ohm, resistance 2 is going to be 2 ohms, resistance 3 is going to be 3 ohms. So we don't have resistance 3 in this problem, for instance. Resistance 4 is going to be 4 ohms, resistance 5 is going to be 5 ohms, and so on and so forth. So whenever I write Ri equal I ohm, whenever you see Ri equal I ohm, generally the meaning is this one. Like, yeah, the first resistance is going to be 1, second is going to be 2, third is going to be 3, and so on. So we can actually write it and say, okay, this is 5 amperes, this is 6 volts, and this one is going to be 1 ohm, this one is going to be 2 ohms, this one is going to be 4 ohm, and this one is going to be 5 ohm. Right. Well, I shouldn't really be telling you that I was going to solve it with the superposition of effects, because once I told you at the very beginning, you already know how I'm going to solve it. Well, you can kind of guess, but anyway, whenever you have two generators, generally one of current and one of voltage, it's almost always the case in which you're going to do like I'm going to do right now, and just like I did before, that you're going to consider the circuit without one of them, and then the circuit without the other one, and then sum the effects and get the final result, which is exactly what I'm gonna do. So as I said, it is called the superposition of effects for this very reason, because the resulting effects of adding the first and the plus the second one, so adding the first to the second one, is going to be like considering the whole circuit. But of course, considering the whole circuit would be very, very difficult and hard to solve. So let's do this. We're going to use the superposition of effects. So my first circuit is a circuit in which there is just going to be my generator of current J, and I'm not going to have the generator of voltage V. So my circuit is going to be, I'm just going to draw it again, just to let you know what I mean. Well, you should know what I mean. It's pretty straightforward, to be fair, but anyway, since it's not that big, if it would have been bigger, I would have been drawing it back again, because but anyway, since it just takes me just a little bit of time, so it's fine. Besides, YouTube doesn't have time constraints anymore, so okay. And this one is the other resistance. So this one is still gonna be my point A, this one is still gonna be my point B, and basically gonna have a difference of potential between those two, which I'm gonna call VAB first. And of course, those resistances are still gonna be R1, R2, R4, and R5. Still gonna say, okay, report all the units. So 5 ampere, 1 ohm, 2 ohm, 4 ohm, and 5 ohm. Okay, so now what do we want to find? Well, we want to find the voltage. But to find the voltage, we can use Ohm's first law. So the voltage will be, remember the Ohm's first law, when we have V I R, like the triangle, okay, or V equal to I times R, okay. So you can actually, you can actually memorize it either this way or this way. Like when you cover V, it's I times R. When you cover I, it's V over R, and so on. But anyway, we want to find V, VAB. So V will be I times R, okay. Well, we know I because it's 5 amps, but we don't know R yet, because we have 1, 2, 3, 1, 2, 3, and 4. So 1, 2, actually 1, 2, 4, and 5. Those 4 resistances. So we gotta find the total resistance here. So which I'm gonna call RT. So this will be RT. Okay. So RT is gonna be given by, well, how are those resistances? Those two are in parallel, okay, and then those two are in parallel. So I'm going to have R1 parallel to R2, and then R4 parallel to R5. So I'm just going to say, okay, so RT is just going to be R1 parallel to R2 plus R4 parallel to R5. So RT, it's literally just going to be 1 remember when you have the parallel and write the parallel like so, it's going to be you gotta have the to multiply those two numbers and then divide by the sum of these two numbers. And again, here you have to multiply R4 times R5 divided by R4 plus R5. So let's just do this. This is like, well, I'm just gonna make one more step just to make it myself clear. This is like saying R1 times R2 over R1 plus R2 plus R4 times R5 over R4 plus R5. Okay, so RT is actually going to be, well, let's just substitute all these with numbers. 1 times 2 over 1 plus 2 plus R4, so 4 times 5 over 4 plus 5. Okay, so RT is actually going to be 2 over 3. 2 plus 1 is 3. 2 times 1 is 2. This is trivial. Then we're going to have 20. And we're going to have 4 plus 5, which is 9. So the minimum common multiplier will be 9. 3, 6, 9. So we're going to have 6 here, and then plus 20. So RT will be 26 over 9. And I don't really like fraction in circuit analysis. So I'm just going to rewrite this as, well, 26 times 9, I'm sorry, not times, divided by 9. 26 over 9 is... yeah, 2.888. So I'm just gonna say 2.88 ohm. Okay, so this is the total resistance, and now we can plug the total resistance here. We have everything we were looking for. So our VAB first, let's just call it VAB first, because it's actually this one that we were looking for. Anyway, VAB first, that's going to be I, which is 5 amps as provided by J, the generator of current. So I, so 5 amps times RT, which we have just found is 2.88 ohms. So times 2.88 ohms. So in this case, VAB first is going to be, well, 5 times 2.88 is actually 14.40 volt. So now we are halfway through, because we're going to be doing the same thing again, but this time we're just going to consider V. And we're not going to be considering J. So I'm going to draw it again. And well, here you wouldn't have anything, so I'm just going to write, nothing. Over here you will have the resistance. Okay, and then over here you would have the other resistance, and then in between there's gonna be the voltage here, the power supply for the voltage, plus V minus. Down here we're still gonna have our resistance R4, and down here is still gonna have R5, happening here? So here it's connected to nothing. It just, there is nothing here. So this one is still going to be my R1, R2, R4, and R5. This is still going to be my point A and my point B. I'm going to have plus minus different of potential here, which I'm going to call VAB second. Whoops, that doesn't look, I messed up the, I hate myself. I messed up the drawing. Okay, so I'm going to call it VAB second. Now, I'm going to do the same thing as before, because now we're going to have to come up with I of t. So basically, I, this time, you know, before we had, we were looking for VAB. In this case, we're going to be looking for I, because then we will be able to find VAB, the real VAB. So what I'm going to be doing here is this. I'm going to be saying, okay, I'm going to, first of all, before even getting into this, I'm gonna have to find the total resistance. The reason is that you know, before we were looking for V AB, so we cover up V, and we have I times R. Okay, so right now we're still gonna be using the Ohm's first law. We're gonna cover I. We are looking for I, so it's V over R. So we're looking for V over R. Okay. There's still the problem that we don't know what RT is, so the R total is in this case. So we're gonna do the same thing again, and then use the and then we're gonna find I. So basically, this is the pretty much the same thing. It's still gonna be R1, but in this case, I'm gonna be doing this. Okay, RT in this case is gonna be R1 plus R2 parallel to R4 plus R5. Okay, because the generator is no longer here, the generator this time is here. So I don't know if you want to sort of turn the page, but you should be really watching it like this, because this generator is here, so you're not gonna have, those two are not gonna be in parallel to each other. So R1 is not gonna be in parallel to each other. They shared this end with the generator. So R1 is in series with R2, and R4 is in series with R5, but those two are in parallel with those two. Okay, so we're gonna get a different number this time for the RT, as we have different values for R1, R2, R4, and R5. So V, as we said, it was 6 volts. We have it here. So I'm gonna write 6 volts. This was 1 ohm, 2 ohm, 4 ohm, and 5 ohms. Okay, so let's do it again in this new configuration. So basically, this time RT is actually going to be, well, R1, so 1 plus R2, so 2, this is going to be parallel to R4, which is 4, plus R5, which is 5. So RT is going to be 1 plus 2, so 3, parallel to 4 plus 5, so 9. Therefore, RT is actually going to be 3 times 9 over 3 plus 9. So this is going to be 27 over, it will be 13, 12. If it was 10, it would have been 13, then minus 1 is 12. Okay, so RT is actually going to be equal to, well, I'm just going to grab my calculator and just do 27 divided by 12 is actually 2.25 ohms. Okay, so this is 2.25 ohms. This is gonna be my RT. Now I wanna find I, because I already know in this case I had to find the voltage because I knew the current in ampere. Here is the opposite. I know the voltage, and I want to know the current in ampere. So by Ohm's first law, the current in ampere is going to be V over R. So V, which we know is 6 volts, over R is actually RT. RT, we just found RT in this new configuration, so it's 2.25. 2.25. So I is actually 2.67 amps. Okay, so we're almost there. Okay, we're almost there. Well, I'm just gonna call it IT, just for the sake of to say that this is the I total. Okay, just to make sure that we're all on the same page about what this is. So now we're really almost there. Now I'm just gonna say, okay, I wanna find, whoops, sorry about this. It wasn't my intention. Okay, so I'm almost there. We're almost done. Okay. So now I'm gonna say, okay, I'm gonna have to find I1 and I4 so that I can actually get VAB second, because in this setup, yeah, we found I, but what we really want to know is the difference of potential in this part, so that we can add it to the VAB first that we found here easily, and we can call it a day. So in order to do this, I'm gonna say, okay, oh yeah, this one is ready. I'm gonna go here, new page, new chapter of a new story. What this story is gonna be about? Circuits. No, I'm just joking. Okay, so basically I'm gonna say, okay, I1 is going to be given by, so the current that is flowing on this end, and I'm going to find the current that is flowing on this end and on this end. So I'm going to call this I1 and this one I4. Okay, so the current that is flowing on this end is going to be a subset of the total current. So since we call this IT, I'm going to be stick with IT as a name. So since it's a subset, it's going to be IT times, just like I showed you before, it's going to be R4, okay, plus R5 over R4 plus R5 plus R1 plus R2. So let's just write this. So as I said, this is going to be R4 plus R5 over R4 plus R5 plus R1 plus R2. So I1 is totally going to be 2.67 times R4, so 4 plus 5, and then 4 plus 5 plus 1 plus 2. So IT is totally going to be 2.67 times, well, 5 plus 4 is 9. 4 plus 1 is 5. 5 plus 5 is 10. Plus 2 is 12. So IT, oh well, no, I1, what did I write? Okay, I1 it's gonna be 2.60. Oh no, I'm just writing it again. Okay, no, it just 2.67 times 9 divided by 12. I'm just gonna use my calculator because I'm lazy. So 2.67 times 9 is 24.07 divided by 12 is 2.0025. So yeah, just 2. I'm just gonna say it's 2 amps. Yeah, sorry about that. So I4, yeah, some mathematicians are screaming like, no, we should keep those. Anyway, I4 is going to be a subset of IT, so I total times, and in this case, I4, so the current on this end is actually going to be R1 plus R2 over R1 plus R2 plus R4 plus R5. So in this case, we're gonna have R1 plus R2 over R1 plus R2 plus R4 plus R5. This is also called the partitioner of current rule, but just just to let you know. So I4 is going to be, well, IT, so 2.67 times, let's substitute this with number, 1 plus 2 over 1 plus 2 plus 4 plus 5. So I4, therefore, it's going to be 2.67 times 2 plus 1 is 3. Then you will have 4 plus 1 is 5. 5 plus 5 is 10. Plus 2 is 12. Just like before. So I4, therefore, it's going to be, well, once again, I'm lazy, so it's 2.67 times 3 divided by 12. So 2.67 times 3 divided by 12 is 0.66. So, and then it's 7, yeah, just, well, 0.67 amps. We're almost there. So now I can finally find VAB second, because VAB second, I'm just gonna say, okay, now I know everything. I can say, I can do a clever trick, which is not a trigger, just applying the rule actually. It's just plainly applying the rule and what we know so far. So I want VAB, okay? This is like the current getting into the, this is like a node, okay? So we would have this current here getting into, this current here getting out from the node, and this current here getting out from the node. And these will be the I1 that we were talking about. This will be the I4 that we were talking about. Okay, just as a reference. But apart from this, the clever trick is that VAB second, okay, from this is actually going to be VAB second plus, and this should remind you something, okay, plus R1 I1 minus R4 I4 equal to 0. Does it look familiar? Of course it does. It's Kirchhoff's law. So we can find VAB second. So VAB second is going to be R4 times I4 minus R1 times I1. So if we just substitute everything, we know that VAB second, that's going to be R4, so 4, times I4, we just found it, it was 0.67, minus R1, which is just 1, times I1, which is just 2 amps, so 2. So yeah, this looks like a D, but it's actually a B. Okay, so VAB, B, can I write a B, capital B? Oh God. Okay, so 4 times 0.67, I'm lazy, I'm just gonna use my calculator here. So once again, so 4 times 0.67 is 2.68, so 2.68 minus 2 times -1. So VAB second is just going to be, well, 2.68 minus 2 is easy. Just 0.68 volts. Okay, because this one is slightly higher than the 2, so this is just 0.68 volts. So now I can finally say, okay, I know what VAB first is, I know what VAB second is. I can use the superposition of effects and say that VAB, the real one, the one I want to find, is actually VAB first plus VAB second, which is actually going to give me VAB of, well, the first one was 14.40, so 14.40 plus 0.68, this is going to give me a VAB of, well, 14.40 plus 0.68 will be just 15.08 volt, of course. So yeah, this is pretty much it. Yeah, honestly, this is just pretty much it. Okay, so I hope it helps and everything is clear. Should be pretty clear. I mean, it's, you know, stuff like this is doable. This is just, you know, you have to, as you can see, everything comes together. You know, in this we had Ohm's first law. We have how to calculate series and parallel resistances. We have the superposition of effects, and also we had the to apply Kirchhoff law in order to find VAB second. So, you know, everything comes together and everything is fine because it leads you to the solution. So yeah, circuits are like that. They're not so bad, like really. They can be bad, like with three phase and other things like imaginary numbers because of I don't know, like impedance and so on. But when you're dealing with direct current and those kind of circuits, really everything comes together nicely and everything is fine. Everything is, yeah, it's fine. It's almost fun to solve. So that's it from this video. I'm gonna call it a day. And in the next video, I'm just gonna have some more examples. But for now, this is fine. Cheers. Bye.